Well, there's a red door. Dan's going to talk about red, but our favorite color has to be gray, right?
Why?
Gray's Anatomy.
Oh.
Good job. See that transition? You're going to have to step away, but thank you for coming and hanging out with us today. You've got a brain for a gift, as you know.
Yes, I got a golden brain.
February 11th.
Yes,
Gray's
back on
back.
February 11th with new
Good luck with
episodes.
this season. Come back and hang out with us too a little bit. I'll dress
Thanks a
better
lot.
next time because you're
Ciao.
very dapper.
Nice
huh?
meeting you all.
All right. Good round of applause for Douglas. Thank you so very much. All right, Dan, we're talking red. Valentine's Day, that's the first thing that comes to mind. That and Kim Douglas and a bunch of lipstick on my face.
Listen, that's all I think.
Red berries.
The thing is, when it comes to red food and purple food and blue food, we're talking about one chemical compound, and that chemical compound is anthocyanin. Anthocyanin comes from two Greek words, anthocyanos, which means blue flower. But what we're figuring out today through this chem lab is why does one chemical get blues and reds and purples? How are we getting all of that? So here's how we're going to figure it out. We're going to extract the color and do a little experiment.
Ooh.
Oh, wow.
So first you need to cut up some cabbage.
Some purple cabbage.
Purple cabbage specifically. Green cabbage has no anthocyanins.
How do you say purple cabbage in that?
Debbie's not here.
Oh.
Put that in a saucepan, and we're going to add distilled water. Distilled water is what you use for chemistry experiments because it has no mineral content. We make it by boiling water until it steams and then collecting the steam, which means it has absolutely no residual matter from other compounds in there. So it's totally pure water. Once that comes up to a boil, you'll see the water gets murky and purple.
Do you have to boil it?
You have to boil it for 10 minutes, and that's what I have here. Now, be careful with this because it's quite smelly cabbage.
Oh, my goodness. Oh, yucky.
Wow.
Nice,
Dan.
Yes, but you see, this is how chemistry labs work. Smells are good things. So right now we're going to take
It
this.
smells like someone.
Grandma?
Yeah.
Is that you?
Yeah.
Wow.
Grandmother's here.
Now you need to make a filter for your funnel. So I'm going to take this coffee filter, fold it in half, fold it in half one more time, and then if you can see here, I'm just going to open one sleeve there. Stick it right in my funnel. Perfect shape. And now I'm going to filter some of this cabbage water.
Now, do you have to go?
That's what I have you here for.
Oh, perfect. Great.
Look at that.
Up.
I was very close. As you can see, I've already got two of them finished. Because this is dye made from a natural matter, we need to preserve it because otherwise it's going to get infested with bacteria. So I have isopropyl alcohol here, which you might know as
Rubbing up.
ding, ding, ding.
You made the color purple.
Thank you. I did.
Yay!
So to preserve
Special
your
day.
dye, you're going to add some of this isopropyl alcohol, about 10% by volume.
What's the purple color called again? You said it's a chemical compound.
Anthocyanin.
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 Sounds dangerous.
It does sound dangerous. Now, once we have that, throw a little cap on it, mix it up, and here we get to do the fun experiment. So like I said earlier, anthocyanin is responsible, like those berries in front of you, from everything from red to dark blue, the color of eggplant skin. So how could one color compound give us so many different colors? Let's see. First,
Anthocyanin.
Thank you.
Boom.
Thank you.
Thank
First,
you.
we're going to test it with an acid.
Pretty.
Now it goes from purple to red there, right?
Yes.
Now here's in a neutral compound.
Wow.
Same color, right?
Purple to purple.
And now here
Darker.
in a base.
No
Ooh.
way. Out of control.
It's blue. So what we can learn from this right here is that your vegetables and your fruits are either alkaline or acidic. You can tell. So right here we've got some potatoes over here that are blue. You have some berries. Now
Yeah.
raspberries,
I ate mine.
raspberries are quite acidic, right? They're closer to this color. This is anthocyanin in acid. But if anthocyanin is in base, this is sort of the color of an eggplant skin.
What does base mean? What's that liquid? What is it?
Well, this base that I'm using right here is just a mixture of baking soda and water.
Okay. And
Now,
what is acid?
this acid that I'm using is just vinegar, acetic acid.
I see.
Now,
Okay.
acids and bases are actually a measure of the availability of hydrogen in any solution, but we'll get into that in another day.
Okay.
Wow.
So that's
Well,
alkaline then, right? You're saying-
Alkaline, yes.
So-
a base and alkaline are the same.
Okay. So an eggplant is an alkaline vegetable.
Indeed, indeed, indeed.
Wow,
It is.
Tanya, look at you.
Look at this.
Well, you know, I'm
Now,
pretty
anthocyanins in general, if you see colors like this in foods,
Pretty.
they are an antioxidant. They're antioxidants for the food themselves. The reason a vegetable or a fruit would produce something like that is to preserve itself. Antioxidants actually keep a fruit fresher. That's why these color compounds are there.
That's
So that's how
Very few
antioxidants
people
exhibit themselves
don't
as
know
color.
this, but what was the color of the very first red carpet?
It was blue. It was green.
It was purple.
No.
It was purple.
Oh.
It was.
Until we spilled acid all over it.
Yeah, no, but it really was. It was
Oh, really?
purple
You really-
carpet. Yeah. I don't have time to explain it, but look it up. It's true. More great ideas from Dan. Be sure to check out renegadekitchen.com.
So good.
We're going to come back, and Dr. JJ, you're up.
Coming up, I'm going to share with you what we know right now about Zika virus.